I'm Daniel. We're going to talk a little bit about async await today. And my goal isn't to give you code that you can go write down and it compiles, although everything in this slideshow does compile. It's that this whole thing that landed in Swift 5.5 is really big and new. And I want to give you a context, a way to think about what all that it is. So don't worry about the code. Just try to take away sort of the general ideas. I want to give you a way to think about this and to start putting these ideas together in your head. So, well, I should warn you, if you haven't seen me speak before, it's going to be a while till I get to the point. It's just the way it is. And the second warning is, of course, this is new to me too. And so the way we think about this is going to evolve over time. So let's start. And I want to start with an example where I have a search term and I want to search the App Store. Okay, so here's a function, results for. I give it a search term, say I want to search the App Store for snacks. And so I have to construct a URL. And so I'll use another method, iTerm search for snacks. And let's see, I'm going to start a URL session and a data task. And you go, oh my gosh, why is it that every async example is about URL session? And my answer to you is, this one isn't. I just happen to start this way. We're not going to do URL session at all. What I want to focus on is the building of this URL, and I'm going to do it in a couple stages. So this iTunes search method, let's look at it, because this one doesn't actually compile. iTunes search returns an optional URL, and data task requires a real URL. So we're going to start with optionals. So here's my iTunes search. I'd love it to return a URL, but for now it's going to return an optional URL, and we'll do it. This is kind of like Apple's URL for string, except we're going to write our own so that we have control over it over the course of this talk. And so this URL returns an optional URL from a string. That's not the actual search string, so I've shortened it a little bit so it fits on the slide, but it's close enough. The point is that URL returns an optional as well. And here's my URL method. It returns an optional URL. And so it calls create URL, which creates a URL from a string. And it looks to see, is this URL valid? If it's not valid, I'm going to return nil. If it is valid, I'll return the URL. So I'm returning an optional if something isn't valid. And in a way, this is a classic use of optional that goes back to UIKit and Foundation, is we use optionals often, or we return nil in classic code for Objective-C as a way of dealing with errors. And so this is an error if it's nil, it's not an error if it's not nil. And so URL returns an optional. And so here's where we called it in iTunes search. And all iTunes search is doing is taking that optional and passing it on. So one thing we can do with optionals is we can use if let or guard let, and we can handle the optional. The other thing we can do is just say, you know, not my problem, I'm just passing it on. And so we're going to take the optional and pass it on. And so whoever calls iTunes search is going to have to deal with it. And that's what we saw here. URL isn't optional. Data task needs a non-optional, and that's why this didn't compile. So let's review what we know about optionals. I know we'll get to the async stuff. If something goes wrong, our optional is nil. And so optionals are one way to deal with errors. And if we have an optional, we have two things we can do with it. As I said, we can either pass it on or we can handle it. And so what we just saw was passing it on. I got an optional URL and I just returned an optional. So we've done that. Let's look at how we might handle it. And so say iTunes search, we're going to receive an optional, but instead of returning an optional, I want to just return a regular URL. So how do we handle it? So I have this URL, it's optional. I can if let it. And so I if let it, and if it's not nil, I unwrap it and I return this unwrapped. And so I'm returning an actual URL, not an optional URL. This shouldn't be new to you, but it is setting up what we're going to do with async. In the case that it was nil, well, we're going to return some valid URL instead. And so we've turned this into something that receives an optional, handles it, and passes on something that is not optional. So this URL is optional, returning a non-optional. And now this compiles because URL is an optional data task want something that's not optional, we're happy. Now, another way we have of dealing with errors in Swift is, yeah, we are getting to async. Another way we have of dealing with errors in Swift is we can throw an error. And so instead of URL returning an optional URL, this method might instead throw an error. And so the same thing, we create a URL, we check to see if it's valid. If it's not valid, instead of returning nil, I'm going to throw an error. And if it is valid, I'll return the URL. And so now instead of returning a URL or nil, I'll return a URL or I'll throw an error. Of course, this ruins the calling code. The calling code was expecting an optional. And so what do we do in the calling code? Well, URL is no longer an optional. I can't if let it anymore. It either throws an error or it returns a valid URL. I can turn it into an optional. I can ignore this throwing bit and I can turn it into an optional using try ? And so you can see that that's that bridge between errors and optionals. I can turn any error throwing into an optional using try ? But suppose I want to actually deal with this thing that throws. I'll use a try without a question mark. My two options, remember, were pass it on or handle it. If I'm going to pass it on, then I declare my method to be throwing. And so this says iTunes search either throws or returns a URL, and that's the response to the try. So just like optional, if we receive an error, we can either pass it on or we can handle it. So try goes with throws, that's passing it on. If we want to handle it, that's a little bit harder because that says I'm not going to throw as a method. iTunes search is just guaranteed to return a URL. And so I can't just try this thing without doing something. I have to, in fact, use a do, try, catch. And so I put this try in the middle of a do and I catch errors. And now I try the URL. It either works or it doesn't. If it doesn't work, I'll return my valid URL. That's how I'll take care of the error. And if it does work, I'll return the valid URL. So this is how I handle it. Now, customers are awful. I designed this code for you to type in snacks or cars or code, but customers don't pay attention. Even though I want one-word search terms, they're going to enter something like crunchy snacks. They're going to search for 2-word, 3-word terms. They're just awful. So I'm going to add a second method, this formatted search, that if you give me a search term crunchy snacks, I don't know if you've ever looked at the App Store URL, it replaces that space between crunchy and snacks with a plus sign. So I've got to format this. And suppose that this formatted search method that produces this term that I'll use, suppose that formatted search throws too. Anything that throws, we have to try. And so even though we're in the same do block, we have two tries. Formatted search can fail, we need to try that. URL can fail, we need to try that. So within one do, we have to try. And we have to try twice every time something goes wrong. So now, believe it or not, we're set up to talk about async. So let's suppose instead of getting an error or an optional, we just take a while to create a URL. It just takes some time. And so when I create a URL, it's going to take me a while. And so I have to wait for it. Because there are things that we could be doing instead of just waiting and waiting and waiting. And so what we do is we put it on another thread. We say, someone else do it. I'll go do other things that I could be doing. And I'll add this await keyword. And await says, I know that you are an asynchronous method, that you're going to take a while. So I'm going to wait for you. And so while you're creating your URL, nothing else in this method is happening. I'm freeing the processor to go do work in other methods, respond to user input, put things on the screen. I'm just not going to take your time. And at some point, after I wait and wait, create URL returns. And it returns with a valid URL. And so now I can come back to life and I can assign that URL to URL. And then I can check if it's valid. And if it's valid or if it's not valid, I either throw an error or I return the URL. But that await said, nothing's going to happen while I'm waiting. Now, remember, when we have a method that throws, we have to indicate to people calling our code that, something could go wrong. And the same thing is true here. I have await, but I haven't told anybody calling the URL method something might take some time. So just as throw requires I have throws in the signature, await requires that I tell the caller, and I do that using async. So async is how I alert the caller. So here's a little sidetrack, and then we're going to be done with errors for the day. This guard URL is valid. Imagine I do this check inside of create URL. So create URL throws an error and it's asynchronous. If I have a method that throws an error and is asynchronous, well, I have to await because it's asynchronous, but I have to try because it can throw an error. And so you would put try await with create URL. And the try matches with the throws and the await matches with the async. And notice the order. It's try await, but it's async throws. And so what Apple did when they designed this await async await thing is they said, we want to mimic what you already know how to do in your error handling. And so you'll notice that the syntax and the style matches it pretty well. Okay, we're all done with errors. Now, create URL isn't going to throw anymore. We don't have any more errors. And so we clean it up. And all we have left is this async await stuff. Create URL takes a while. So we async await. Now, somebody calls this method URL. And URL is marked async. So whoever calls it is going to have to await for it. So iTunes search is where we call this URL. And since URL is asynchronous, you know that this doesn't compile yet. We have to await for it. So anytime you have something that's asynchronous, you have to await it. And anytime you have something that's await, either you handle it or you pass it on. So if I run this code, I'm waiting for URL to return. It's asynchronous. It's going to take a while. When it returns, now I can come back to life and I assign that value to URL and I return that URL. So this await is sort of a message to you saying, I'm going to suspend this thread. You're free to do other work. This is happening somewhere else. Now, when you come back, you might not come back to the same thread, but that's sort of beyond this talk. Now, this doesn't compile because there's an await inside of this method. Either the method has to be marked as async, or we have to handle the await some other way. Those are our two choices, just like optionals, just like errors. With async, there are two choices, either pass it on or handle it. So to pass it on, I would add an async there. Then someone else, whoever calls iTunes search, has that same thing. They have to await iTunes search and they have to decide, am I handling it or am I passing it on? So let's take a look of, instead of callers of iTunes search having to await and maybe they have to pass it on using async. Oh, this is different and interesting. Results for doesn't return anything. And yet I've still labeled it as asynchronous because if you call it, you're going to have to wait. So even a method that doesn't return anything can be async, including an init. You can have an init that is async because you're doing work inside of that is going to require waiting. So if you call results for, now you'd have to await. So at some point you have to stop, just like we stopped with a do, try, catch. That's how we stopped our errors. There has to be a way of stopping just passing on every await call with an async. And so, for example, I'm calling iTunes search. iTunes search is await. This doesn't compile if I don't have await here. It turns out this still doesn't compile. Now you say, Daniel, just label search for is async. Yes, but then it's someone else's problem. Let's see how we handle it instead of passing it on. So to handle it, we wrap this in a task. Now, Apple did something very cool. This used to be called async with lowercase, and they renamed it task during the beta period, and they went back to the dub videos and they reshot those parts using task. So the code in dub is still correct because they've updated it. So task await, this spawns another task. And so search for finishes, the task is happening somewhere else on another thread that's been spawned. We've handled it. If you call an async method, you have to use await. And if you have something that is await and it's inside of a method, your two choices are either you declare the method as async, that's how you pass it on, or you handle it by capturing the await part in a task. And there's task and task detached. And again, those are beyond the scope of this talk. Okay, that's how we deal with one asynchronous item. What happens if we have like a whole series of them? What happens if we have this series of unfortunate events, which is actually a sequence of asynchronous events? Asynchronous sequence, that's async sequence. And that's also new, and it's part of this whole thing that's been released to us. And let's see how that works. And I'll do that by looking at an example that is posting notifications. So if you've worked with the notification center, you know how to post notifications, you know how to receive notifications. You probably either use the callback method to receive notifications, or you use the closure method where you pass the closure forward to the notification center. And then maybe a couple of years ago, you learned the combine method. So it turns out Apple introduces async await. They've gone back to the notification center and added something new this year. So posting notifications, nothing is changed, but let me just look at this example. I have a notifier. It has a single property. It is an int called number. And when a user taps a button, I'm going to post a random number. So first we'll create our random number. So we're setting this property. So now my notifier has a property named number with this value. And now I'll go ahead and tell the notification center, I'd like to post this notification with myself as the object. So you can look inside of me and find my number, and you'll know what my random number is. So I'm posting a notification. How do I receive this notification? So think back to all the ways you know how to do it. I'm going to do it inside of something called a receiver. A receiver is going to have a single property that is an int, and I'm going to set this int, and this int will be published on to the UI, which will be able to post it. And so in my init, I'm going to call my register for notification. And by now in my slides, you've caught on to this. See all that space to the left of register for notification. I bet stuff is going to go there later. So I'm going to register for notification, but there's going to be some details. So let's look at register for notification. Register for notification is going to start with the notification center. And here is notifications named object. This is the new API that Apple added. And what this returns is a sequence of notifications. So it's not a callback. This is a sequence of notifications. In fact, it's an asynchronous sequence of notifications because I'm going to get a notification whenever one is posted. I'm not going to get my whole sequence of values all at once. I have to wait until they send me them. So I have my asynchronous sequence of notifications. And Apple's done another wonderful thing, which is you've worked with sequences. And so you know higher order functions like filter and map and compact map. Well, they work with async sequence too. There's async sequence variants for those. And so I can go ahead and take this async sequence of notifications and use compact map to take my notification, to check that there's an object inside. Object is an optional, so it may not exist. If it does exist, I'm going to check that it's the right type. And when I'm done doing that check, I either stop, it's nil, and compact map swallows those up, or it's not nil, and I have an async sequence of notifiers that gets passed on. Notifier had that single number property. That number was an int, and so I can use map to reach inside and get that number. And now I have an async sequence of ints, and I'll save that in numbers. Now, this is the fun part. Numbers is an async sequence of ints. You can imagine it as a sequence of ints that comes to you over time. And so I'd like to iterate through them just the way we would iterate through a sequence. And so the way I would iterate over a regular sequence is I would use a for loop. And I'd say for every number in numbers. And that's how I would iterate over my sequence. And so every time I get a number, I would assign it to that property, that self.number. The problem here is I don't get my numbers all at once. Some may come today, some may come tomorrow, some may come in a week. And so because numbers is an async sequence, I can't just iterate it using a for loop. I do for await in. And what for await in says is, wait, when you get the next number, I'll assign it to number. Number will be assigned to self.number. So await says it may be a while. Whenever you get something, will come back to life and you'll be able to execute the body of your for loop. This is to me delightful that they've made it just so familiar in a way that they've sort of hidden a lot of the complexity. So this is where we've assigned number to self.number. Because we had to await number, register for notification has to be marked async. Remember, when you have an await, either you handle it or you pass it on. We have to pass it on because numbers could be running for a long time. And so this is async. And that brings us back because register for notifications is async. The caller has to wait for it. So that tells you what made this not compile. When you call register for notification, it has to be with an await. And because it's an await, either I have to mark my init as await or, and that would be passing it on, I'll handle it, and I'll handle it by putting it inside of a task. So again, new syntax for many of you, but now you've seen it several times and you see how they're very consistent with it. The task executes on a background thread. And so that's a bit of a problem because we're trying to put things into the UI. Remember, inside my for loop, I'm assigning to this number property, number is published, and publishing to the UI needs to be done on the main thread. So how do I get from some other thread back to the main thread? There are many ways, but one of the nicest ways is we add this at main actor. And what at main actor does is it says every method call, every property getter set will be done on the main thread. Inside, I might push the background to do something, but the calls will be done on the main thread. And this way, I won't get a warning at runtime saying, I don't think you know how to use this. So I'll get back to actors in a minute. That was the main actor, but there's something else I want to look at, which is what about combine? You know, some of us have been using combine for a couple of years. And what you might have noticed is this example showed how I get from async to combine. If we look at this code, you can see that numbers was an async sequence. And inside of this for loop, I took the values as they came to me over time. For await in says the number might be delivered over time, and I assign it to this property that is published. That's a combined publisher. And so I've gone from an async sequence to combine. And something cool that happened is not only can I go from async to combine, but as of a recent beta, Apple has given us the other direction. And the reason is there's some things that combine does that async can't. There's some timing-based functions such as debounce. Async doesn't do that, combine does. There's combine latest. I can zip two things together, but combine latest is updating when either one of them changes. It's not just waiting like a sequence zip. And so these are things that combine does that async doesn't, at least for now. And also, some of us have existing combine code for iOS 13 and 14. It would be nice if we can bridge that back into this nice async APIs. So what we want to do is be able to go from combine to async, and that's the bit that's new. So this highlighted notification is how we did it in async. That gave us an async sequence of notifications. The way we do it in combine is we get a publisher for, and that's the combined publisher. But now everything red and above, so that's a combined publisher, and everything below is dealing with async sequences. How do we bridge from one to the other? and Apple recently gave us a computed property, and that computed property is called values. And so we take this and we put dot values underneath, and dot values is what takes a combined publisher and turns it into an async sequence. And so that is how we bridge in the other direction. And that's kind of nice. That gets us from combined to async. And now we can go either direction. And I think you'll find now you can reach for whichever tool is most convenient for you. So you don't have to forget the things you knew from combine, or if you didn't learn combine, you don't have to worry about picking them up. You can pick and choose from whatever tool set you like. So let's take one last look. I mentioned that we're going to come back to actors. And so let's come back to actors. An actor, as my example, is I'm going to imagine that yesterday I did a Fitness Plus workout. And at the end, I offered the trainers that I worked with a lovely pumpkin spice latte. So each of us connects to an order. And in an hour, I'll place the order based on who said they want one. And I want to look at various ways of doing this to motivate actor. And my wrong step that I'm going to take first is let's do order as a struct. And if I do order as a struct, it has a single property, which is names, which is an array of strings. So each person can add their name to the list of who wants this pumpkin spice latte. And you add your name to the list by calling order dot place order. In place order, you'll submit your name, and it will add it to this by saying names dot append. Now, we don't think of this very often, but there is time between names and the dot append, and that's going to come up to us. But first, let's look at our wrong case one. Let's work with our struct. And so I'm doing my workout, and I had Anya and Bakari and Greg and Jessica, and each one of us get order as a struct. But a struct is a value type. And although mostly we should work with value types, there are two cases, and Apple has been consistent since Swift shipped. They said you should prefer value types to reference types, except when you need inheritance and then you're stuck with classes, or you want reference semantics. In other words, you want to be able to share with this single mutable state. So if I use a struct, everyone has their own order. And so when everybody adds their own name, they place their order. Their arrays each contain only their name, and I don't see anything at all. So structs are not the solution. What we want is a shared mutable state. We all want to be talking to the same state. And so I'll have a single order, and this order instance is our second wrong case. It's the class. So the only thing that changes is it's a class, not a struct, and the method no longer has to be mutating because it's a class, not a struct. So we're all talking to the same instance of order. Now, when you place your order, notice that we take names and we add your name to the end of the array. And so when you get the array back, you get an array of strings, and your name should be the last name in the list. So let's run it. Let's suppose that Anya places an order. And so when she places an order, she calls this code. And when she calls this code, she sees an empty names. She appends her name to that. And then it gets returned to her. And I'm going to abbreviate that as just A. And then Bakari places his order. He sees an array of names that includes Anya. He appends his name to that. It gets returned to him. He sees an A and a B. This is perfect. Notice she has an array that ends with A. He has an array that ends with B. Everybody's happy. Now, suppose that Greg and Jessica use tasks, and so it's not clear whose request is going to get there first. If Greg and Jessica use tasks and things are contending, they both place their order concurrently, and now I got to worry about who gets there first or how it goes through. And it turns out there's 4 situations. Now, to better understand this, what I'm going to do is I'm going to imagine that I'm going to lose the connection to the order. And so at the end, I'm going to say, who has the most names, and I'm going to send in that order. So there's 4 possibilities. Here's possibility 1. They're placing them concurrently, but as it happens, Greg's order gets there first and it completes. So let's see. Greg calls in first. He places his order. He sees Anya and Bakari. He adds Greg to the end of the array. He gets back ABG. Jessica gets in there next. She sees Anya, Bakari, Greg. She adds her name to the end. She gets back ABGJ. She's perfectly happy. Case 2 is the same thing, except Jessica happens to get there first. And in this case, Jessica sees Anya Bakari, places her order, adds Jessica to the list, gets back ABJ. Greg gets there next. He sees Anya Bakari, Jessica. He adds his name. He gets back ABJG. Perfect. I say, who's got the most? Greg says, I've got the most. There's the order to complete order. And all 4 of them, they are the last element of the array that they see. So let's see where this goes wrong. There's 2 ways this goes wrong. One way is they both call the method, and inside of the method, they both get the same names, and now they both append to not the name that includes each other. So Greg and Jessica call at the same time. They both look at names. Names is Anya and Bakari. So Greg appends his name to Anya Bakari and gets back ABG. Jessica appends Jessica to Anya Bakari. She gets back ABJ. I don't know what's going on in names. I do know that when I say who's got the most, I've got a tie, and they don't even agree. The second problem is there's a clash. Each one updates, but there's a pause before the names get returned. And in this case, Greg and Jessica both place their order. Greg has Anya Bakari. He adds Greg. Jessica might see Anya Bakari and Greg and add Jessica. So what's happening internally is correct, but Greg's return names doesn't happen until Jessica has appended her name. So the internal state is correct, but both of them, if Greg got in first, both of them are getting back Anya, Bakari, Greg, and Jessica. And this is a problem, even though when I say who's got the most, they both agree on what's there. Notice Greg's name isn't last in the array that was returned to him. And so there's still a race issue and a problem. And in this case, it doesn't matter. I'm just ordering lattes, but there are cases where it is going to matter what's actually sitting in the array that you have, because it doesn't match what you're expecting. So the solution is to make sure that this place order is done without anyone interrupting. So if Greg gets there first, he goes through all the steps before Jessica gets in. Or if Jessica gets there first, she goes through all the steps before Greg gets in. And that's where actor comes in. So actor is a reference type. It is shared mutable state, but it restricts access. And it's a reference type that you can't create sub-actors. So there are no minor actors, only minor parts, I guess. Okay, so here's my actor. Looks exactly like a class, but it places restrictions. If Greg calls in first, Jessica has to wait. If Jessica calls in first, Greg has to wait. And that means when you call place order, if one has to wait, I have to use await when I call it. So this does not compile. I can't say order dot place order for Jessica. I have to note that it might take some time because someone else might have ownership of the actor at that moment. And so anytime I call something in an actor, I'm awaiting. It's another thing that might wait. I have one last example. Suppose we're going to order lunch for a trainer, and lunch consists of salad and drink because they're trainers. And it takes a while to prepare a drink, and it takes a while to prepare a salad. In other words, make salad as async and pour drink as async. So I'm going to order lunch for our trainer. I order lunch and I say, here's the salad I want. Here's the drink I want. It's async because it's going to take a while. I make a salad that is got to be awaited for because it's going to take a while. I may pour my drink. That's going to take a while because it's an async function. And now when I put them together and return a lunch that consists of that salad and that drink, here's what happens. Let's run it. Someone orders lunch. They say, I want the kale salad and I want sparkling water as the drink. And so first we make the salad, and that's going to take some time. When it returns, I can assign that to prepared salad, and I can go on to pour the drink. That's an await. It's going to take time. When I return, I assign it to prepared drink, and now I've got my prepared salad and my prepared drink. I can go on to the last step and return a lunch. Now, that means I couldn't start preparing the drink until the salad was done. But I've got a restaurant where someone could be making the salad while someone else is pouring the drink. I'll wait to return lunch until they're both ready, but they can both go at the same time. So I'm not going to wait anymore. Instead, I'm going to use something new called async let. And async let spawns a task where I make the salad, and it returns when it returns. In other words, someone is making the salad while someone else is pouring the drink. Because these are async and I don't know when they're done, I need to await. And this says you need to wait until both the salad and the drink are ready. Don't care what order, don't care what. I just need all my component parts before I continue. This is called structured concurrency. And that's the last thing. And so I hope I've achieved my goal and shown you some of the things that belong in this async await family. Async await, task, async sequences, connecting to combine actors, and structured concurrency. Read the proposals. They're well written. They're well reasoned. It started as this mass and then it got split apart. A lot of them depend on other parts, but it all comes together. Watch the dub videos and just play. Unfortunately, playgrounds are not as friendly to this as you'd like them to be, but you can create projects and they work really well. Thank you.
Okay, I will unmute. Whoever wants to ask a question can unmute themselves.
No questions? Did you have fun?
I have a question, and yes, I had fun.
Okay.
The question I asked this question in the chat before he addressed it, but because this does a lot of what Combine does, and you explained how they're compatible. There's some things that Combine does that the async await can't do. Is your general thought that if you're starting something new, would you first reach for the async await solution as opposed to combined publishers and subscribers and all that stuff? In other words, would you now relegate Combine to just those special cases where you need something Combine specific? Because this looks easier to me to do. I still think both of them have a pretty steep learning curve. But I just want to know what you found.
So a bunch of things. One thing is async await. This is clearly Apple's path forward. That said, a lot of people, including Apple, are using Combine and are using it well. I really like the Combine way of thinking because you build your pipeline and then you kind of let it run. And so I really like that. people were using Combine for multiple reasons. And I think what async says is, well, if you're just using it for the asynchronous stuff, you can often use the async APIs, and they're very friendly. Apple kept saying you're writing linear code. What Combine is primarily good for is people that are writing sort of a reactive style. And Combine is still a great solution for that. It's so hard to tell with Apple if they're walking away from Combine. My guess is no. My guess is it's going to be with us for a while. In particular, how many developers, particularly at big companies, have to support 2 versions back. Async is iOS 15 and above for now, and macOS 12 and above for now. And so Combine is your only solution for some of it. Also, Combine's awfully pretty. I like async await too, but Combine's awfully pretty. And my final thing I want to say is I'm really old. And so I remember when Apple gave us Grand Central Dispatch and they said, it's going to cure all your pains and it's going to be wonderful. And this year when they gave us async await, they said, oh, Grand Central Dispatch was awful. It was full of things that could make your code work worse. And so I'm waiting to see, as people start using this in anger, are there issues that we need to think about? It sounds like it's really well engineered, and it sounds like it's our way forward. The other thing I would say is these things that Apple's been releasing, Swift UI, Combine, async await, these things are really built with Swift in mind. And so I really like that we're getting a lot of things that are thinking of Swift first and not of a language that consists mainly of classes. And so I think we're rethinking. You heard this message of prefer value types from Apple in 4 or 5 of the async sessions, and you haven't heard that for a couple of years. So I think what you know already is still valuable. In a new project, would I reach for async await? I would, but I'm just nuts that way.
I mean, we haven't even switched to Combine yet because we're still supporting iOS versions older than 13. So I just wonder if
So as you go modern, you're not going to have much of a choice. People have been pushing Apple to support async await in previous iOS releases, and Apple's answer so far has been, yet not planning on it, but we'll consider it.
okay. So we should really just await. Sorry.
Well, but there's going to be 2 years, and the advantage to you, the advantage to you, if you haven't supported iOS 13 yet, is by the time you go to iOS 13, a lot of people will have really solid patterns for Combine. And by the time you come to iOS 15, a lot of people will have really solid patterns for async await. So in some ways, you're getting the best of all worlds. You see what's coming, and you can take advantage.
Right. Yeah, I just like the idea of not having to store the the cancelables and stuff.
So yeah. I think that's less of a deal than people make of it. For instance, in notifications, you're supposed to store the token when you do closure-based notifications, and that's people don't do that. The cancelable is essentially the same thing. And once you get to iOS 14, there's a version of assign to that as long as you're republishing the value, you don't have to store it. You treat it as an in-out parameter.
Oh, okay.
And so that was the only method added to Combine in iOS 14 was assign to with the ampersand.
Okay, a question from the Slack. What's the current support for cancellation in async?
I don't know. They talked a little bit about it, but I haven't played with that at all. The sessions are surprisingly dense and full of great information. I think they did an awesome job this year with that. Anything else?
Nothing.
I have a bit of a question. This might be kind of vague, but have you found using the new concurrency features or really even combine, have you found that it's changed your sort of pattern of doing things? I don't know if you want to talk about like architectures specifically or something, but have you found it changing the way that you write your code?
It really has. So with Combine, I really liked building the pipelines, and something I do in Combine, so unfortunately, when Apple presented Combine, they've done no sessions this year or last year. It's only 2 years ago when they first introduced it. And all of their examples were on a single slide. And just as I break up my classes into smaller pieces and methods into smaller pieces, I break up my Combine pipelines into very small, it does only this, and they're reusable pieces. And so I don't know that that's a rethink so much, is because that's something we've been doing since, Smalltalk, but having very short, testable, easy to understand methods and pipelines, I think is essential for Combine, and the same thing for async. So I think it's just pushed me to do more of that. I don't want these long methods where, oh my gosh, what went wrong in here?
Anybody else with questions? Anybody else with questions? If not, thank you, Daniel. It has been a pleasure hearing from you.
Thank you all.